Hi, I'm back at it. Um, I can't actually remember the last time I did stuff on this. It wasn't that long. It was only a few days, I think. Yeah, this was about 3 days ago, it seems. And what I want to do here is add components into the mix for the entities. I've been kind of on and off about this. I've been like, you know what? I kind of want to do it just because it makes things a lot easier when making entities and stuff. But also, is it going to be too much for, the kind of thing that I'm wanting to go for, which is Game Boy Advance style stuff. I'm thinking, sure, the graphics and stuff should target Game Boy Advance style things, but the actual like the size of the executable and how well it runs and stuff like that, I also want that to be also like Game Boy Advance. So it should be very small and run very fast, basically. But I'm also thinking that doesn't really matter that much because I'm not focusing on optimizations at the moment anyway. I'm just kind of doing things willy-nilly, not caring about stuff. But yeah, anyway, I just kind of want to add in components because it just makes everything easier. And it's not going to be, a normal entity component system because we'll have the entity class, which just has like a vector of components that it owns, and then components will be derived from component and stuff like that. It's still very much object-oriented kind of route of doing things. It's definitely not your typical ECS or an ECS at all, really. But I'm not really trying to make it like that because I'm used to how Unreal Engine does stuff. Unreal Engine does something very similar to this, so it's just better for me, really. And it is my engine, so I kind of get the final say. Anyway, am I using Master for SFML 3? I feel like I am. Yeah, I'm using Master. That's fine. So, what was I doing last time? I don't even remember. I have this... Oh yeah, the registering classes and stuff. And the localization strings and things. That's all cool. I don't really want to touch any of these at the moment. But that's good. So, yeah, I have done some experimenting with dynamically linking libraries and stuff as well. And I also remade the class registry system to be used in a DOL, in a Windows dynamically linked library. And where is it? This function here doesn't work well with dynamic libraries because dynamic libraries, or DOLs in particular, I think they have a separate almost translation unit. I don't know if that's what it's called exactly, but they have a separate environment where they have all their static allocations and things, and then the executable has its own other environment. And so this variable gets created in the libraries environment as well as a separate one being created in the executables environment, meaning you have two. So everything's going to get registered twice, one in the libraries one and then one in the executables one. And obviously that's not good. So what I figured out is the way to fix this is just turn this function into a singleton, and then you do only get one. You still have the classes trying to register themselves into it twice because you're including them both of the headers in the executable and the library. So because they're two separate things, they're going to try and register in both, but only one of them will succeed and the other one won't because the other one succeeded beforehand. And I believe they still reference the same class. So yeah, anyway, I did some tests and things. I don't think I'm ever going to support dynamic linking with this engine though. I might, I don't know, but I can probably change that later. It wouldn't be too terrible. But for the time being, at least, it's going to be static because I want everything, all of the libraries and stuff, to just be in the executable. Everything that isn't in the executable is just external assets and resources like textures and sounds and stuff, all of the libraries that it uses will be embedded in the executable, just so that you have one exe and then all of the resources and assets that it relies on. That's kind of the plan. Right, let's get into components. I suppose first, I probably shouldn't have opened Rider. Well, no, actually, I did realize, I don't know this before, but I did realize that Rider updates automatically, so that if you do your CMake thing and you regenerate the build file stuff, then you don't need to close and reopen Rider. It just like updates, so I can just leave Rider open all the time, which is great. So if let's make a component class. I was also thinking, do I want to like make these into separate folders and stuff? I'm not going to at the moment, but I might. Well, no, I probably shouldn't any kind of later than this, because it's going to be really annoying to kind of change all of the includes in the files. So no, I think at this point I might as well just stick to having files just be sitting there all in one list. It doesn't really matter, because they're all going to be called different things anyway, and also there's not going to be many more than there is now. It's just going to be different kinds of components and, like, I don't know, maybe a few more different things. It's not going to be that many files. So we can make the component. Like so, put it into CMake. And then make the source file. Would I want it in an interface? I wouldn't want it. Would I want an interface? What did I do here? I just had this. Okay, I mean, it could be an interface. I'm going to leave it without a source like file for now. Yeah, so if I go back into Rider, we have a component header now. That's pretty great. Tails. So this obviously wants to inherit from objects. Yeah, it can't really be an interface anyway, because it's inheriting from objects and stuff, so it yeah, it can't really be an interface, but you know, one can dream. We want objects, we also want tickable, and we don't exactly, do we want drawable? They're not all going to be able to be drawn, but we also need a way of drawing only the drawable ones. So I don't know how I'm going to do that. Maybe I just give them all a drawable thing. But for now, I'm not going to. I'm also going to have a protected, which returns a float rect. It's going to be getting the global bounds. Of the component, and I suppose the global, it might not even would it even return the global bounds? Maybe, like, yeah, because obviously some components don't even need to return global bounds. Like if you have like a camera component or something which gives you like a view, well, no, that would have global bounds. That's a stupid example. What if you had like, you know, literally any non-visual component? I can't think of any. Sound component, right? Something that plays sound. If you had a sound component, you wouldn't want it to have global bounds. You wouldn't want it to draw or anything like that. So maybe I have a component base class, and then I have a drawable component which has the global bounds and the drawing stuff, and so then the camera would just be a drawable component or whatever. I don't know. Screw it. For now, we're going to have everything be child of of drawable as well. Just because, why not, basically. I'm also not going to have it be that. I'm going to have it be just return nothing, essentially. And I believe this is default. The default is, I assume that's just 0 and 0 for the floats at least. I don't know, probably. Anyway, yeah, so yeah, we can give it the option to not return any bounds or just return 0, and then that will be our no bounds thing, because obviously we don't want to test for collisions and stuff with something that doesn't have any bounds. And then we can have our like templated functions in the entity and stuff. So then the rest is going to be like working with pointers, so we don't care about the child classes until we actually implement them. So now in the entity, we can go into the header, and we can forward declare the component and get our list of components. So this will be turned into some kind of sprite component instead of just being on the entity. And then this will, no, that's not what I thought it was. The actual checking for a collision, colliding, this will change to checking if any of its components are colliding with any of the other components of the other entity. So I'm going to leave this in for now, but I'm going to have a vector of unique pointers to component, like so. And just for the sake of being explicit, I'm going to include those two headers as well. These are saying, yeah, I should probably change riders like naming conventions for this project, because I forgot you could do that. What's this on about? Default. Okay, yeah, we should probably have a little look at the entities, copy constructor and assignment operator, and also the move ones as well. I should probably have a little look at those. But first, I want to quickly. Here we go. I was in it before, so that's why it came up immediately. Right, classes and structs. Prefix with C. We want it to be upper camel case, and we also want structures to be S. So either of these is fine. Concepts. This just wants to be upper camel case. Enums upper camel case. Prefix with E. Unions. I don't use unions. Template parameters. Sure. Parameters. This is just function parameters. That should be lower camel case. Local variables. Lower camel case. Global variables. Lower camel case. No, upper camel case, but prefix with G, even though I'm not going to use global variables. Global functions, lower camel case. Class and struct methods, lower camel case. Class and struct fields, lower camel case. Prefix with M underscore. And then public fields, just lower camel case. Union members, don't care. Enum members, upper camel case. Namespace is lower, yeah. Type def should be upper camel case, and I believe we should now just have nice viewing. There we go. Very nice. We still get this for the copy and move. So obviously, if we didn't have, this unique pointer stuff here, then it's not going to complain, I don't think, because this entity class is now trivially copyable. No, it still does, but it is trivially copyable and trivially movable, because these are like quite primitive things, and that's all its like members are. How big is this, by the way? 312 bytes. Okay, but if we add the unique pointer, it suddenly becomes a lot more complex, because unique pointers cannot be copied. So we can do the easy thing and delete the copy constructor, like so. and then also delete the copy assignment operator. And then just have default moves. Default moves. Cool. Default, yeah. And then default move operator. Move assignment operator. Yeah, default. Right. And then this will, be fine. But if we did want to support copying or duplicating entities, which we probably do, then we can specify that or something, or just have a clone method or something. Yeah, assignments is fine being default, I think. All right, so do we want to have these component functions like create component, get component, that kind of stuff? Do we want them to be protected or public? Maybe the create stuff should be protected so that other entities and stuff can't just add components, but they can still get them. Whatever, I'll put them all in public. Doesn't matter that much, does it? And we also want to say, I want to go to concepts and make sure I have one that derives the component. I could just say derived from, actually. I don't need to. I don't know. I could just say derived from and just do a shorthand for the standard one. But you know what? Whatever. Whatever. Component here. So if this derives component, then we can return it and we can say create component. And we want to have I think I might have listed. Yeah, we have 3 separate create components. One is just creating from the class name without any kind of casting done to the specified one with a template or whatever. One of them is created without the registry at all. So if it's not registered, then you can use this. And then one of them is combining the two where it's from the registry, but it casts to the desired type so that you get the correct type back. So this one is for, when you're loading from like JSON or something for the level, or you're loading the entity or something from some kind of external file, you can just create it without caring about the derived type explicitly. This one's if you want that, but you also want to know the type, and then this one's for just if it's not registered. So those three separate ones, I think, should work fine. This one obviously can be done in the CPP source file, but these two obviously need to be done in header. So this one is going to just be without the registry, meaning we use the new object without the registry. So say components in place back, and we can just say new object, I think. And then with the outer, because we don't want the name, we want T, and then outer is going to be this, and then we can return a static cast to T from the back of the vector, because obviously it was just allocated at the back, so that means the back one is the one that we just added. And now we can have the one that is in the registry, which will be essentially the same but using a slightly different alteration of the new object thing with the class name. And once again cast it back. And then finally we have the one where it just returns the default parent. This can be done in the source file, where we in place back again, but we just do new objects and specify the class name and this. Although, obviously C object, so we've got to cast this to component pointer. Target pointee type is incomplete. Oh yeah, obviously, got to include in here. Here we go. And then we can just return. We don't need to cast this because obviously the type of the vector is component, so just returning that, so we don't need to cast it to T or whatever. And this is obviously going to say do not use static cast to downcast to derived, use dynamic cast instead. But I already know that this is going to be, actually no, I don't know that it's going to be, but it should be. Yeah, sure, whatever, I use dynamic cast instead. Okay, so now we have create component. Now we can get component, which if I bring this back over, yeah, we can get component just from its type, or we can get it from its class name. I don't know exactly how to do this because obviously we can't query the class name of a type. We don't have that information. The type doesn't know what its own class name is, basically. I did do some experimenting with setting a static like class name member of type like string, and then every time you register it, it sets that static member's value to this, but it wasn't working for some reason. It would be cool to investigate that, but for now, I think this is the only implementation that we're going to be able to have. It would be nice to have this one though. I don't know if this one would be useful at all. But yeah, this one's going to be the one that we kind of have at least. So we can once again say derives component. We want to get the component, and we just want to loop through all of the components until we find one that successfully casts to the type T, basically. So we can say comp is going to be for each component, and then we can just see if we can assign a thing here. Can we do casted comp is equal to dynamic cast to T from component dot get. So if this cast succeeds and this is a valid value, then that means that we've successfully, found the thing, so we can return the casted component. Otherwise, we can just return null, a null pointer. So that's nice. So what else? Obviously, we have to have if this is colliding or not, right? The entity, its colliding function needs to be changed to support this. Also, by the way, these can be added in like the constructor, similar to how Unreal Engine you can add components in the constructor, because they don't rely on the entity's outer. For the most part, I think if what you're doing doesn't rely on the outer of the class you're doing it in, you can probably do it in the constructor. If it relies on the outer, you've got to do it in like create or spawn or something, just so that then the outer is actually set before that function's called. Yeah, so colliding. This function here, currently it's just checking if the global bounds of the entity and stuff, they're matching. I don't think the entity does need global bounds, but it's going to be calculated differently because we're not going to have vertices. I'm going to delete them for now. And we can, I'm not going to delete them for now, that's too harsh. Let's leave them in there. Let's just work around this and delete them later. Because obviously the entity is not going to have a set texture function and stuff like that. That's all going to be in the sprite component. So what we want is probably, well, yeah, I can just do it. What am I saying? So obviously, if entity is false, we could have a reference here, that'd be fine, but obviously it's easier to just say this, or whatever pointer it is. It's easier for the users to just have a pointer here, so might as well. We can do a for loop to loop through all of the components of the other entity, or well, through our entities for our entities first, or the other entities first. Let's do our entities first. And then we want to see if the components get global bounds, which is protected. I don't know why I made it protected. Let's make it public. If the global bounds is equal to 0, which obviously that doesn't have a thing, so we want to... Can I even do this? No, this needs to be a thing, because it's obviously 2 vectors, and this needs to be a thing. No, I don't think I can... I could just say float rect. And then, yeah, just that I think would work fine. Then we can continue. We can go to the next one in the loop, because obviously this one that we're looking at doesn't have any bounds, so we can't check it. And then we want to loop through the others thing. Other comp will be entity components. And then here we want to see if that global bounds is equal to just that's a float rect. If it is, we can continue in this one. Does this have like a... No, it doesn't have a, is valid or something. So if they both have actual global bounds that we can use, then we just want to test against them. We want to find the intersection between the first one and the other one. If they succeed, return true, and this entity is colliding with the other entity. And then, if not, return false. I mean, this should work, I think. So that's our colliding thing, if this entity is colliding with another entity. Obviously, if neither of them have components which have bounds, then they can never collide. Yeah, so obviously the level doesn't need to change, because the level's not looking at the components, the entity is looking at the components. So the entity is abstracting the component stuff for the level, basically, which is quite good. So let's turn this into a component. And I'm thinking we have a sprite component, and then we have a child of the sprite component called animated sprite component, so that then it abstracts it out a little bit or something. So we want a sprite component, and we can have a bunch of stuff. We can have like camera component, sprite component, audio or sound component, maybe music component or something, tile component for tile maps, or like literally a tile map component. I don't know, but lots of stuff can be a component, which is one of the main reasons why I wanted to do this over a big entity hierarchy, because components are really cool. This will be a sprite component. Yeah, cool. And I almost certainly will need a source one for this if I add it to the CMake. I can make the source file for the sprite component. And then add it to CMake naturally. and then we can run CMake again, and then Rider will do its thing. Okay, nice, got our sprite component. So obviously we want to include the parent component. Inherit from component here. And let's just take this, put it into here, include the relevant things, vertex array, and text seems to be forward declared in vertex array or something. Maybe not. What? I don't know. But anyway, I'm gonna forward declare it just in case. Here we go. Okay, so now we have that. What else do we need? Let's just look through here and see. Obviously, we need our global bounds thing. I believe I could just make that private. Yeah, because obviously I'm not going to access this directly from this class. I'm going to access it from the component interface. Can we mark no discard? Does that not carry over? Suppose not. We can implement this not as this, but as what was I doing it here? Let's just copy that, really. Get transform, obviously because we're not inheriting from transform. Components have no transform at the moment, obviously. We need to do that as well. Completely forgot about that. Let's include that as well. I like to be quite, not verbose, but clear about, like, if I use anything, I'll want to try and include it. Just that there's no, implicit includes going around. So we have a get transform now. The problem that we're going to run into is the entity is not actually using the transform of its components, or the components aren't using the transform of the entity or whatever. So in the entities draw, we do want to draw the children, and let's do it here. And we can say target, actually, yeah, because we don't need this draw. We don't need this either because it's not going to have a texture. So we could just say target.draw the component with these states. These states will have the transform of the entity, meaning that the components are offset by the entity's transform so that they essentially follow around the entity. The tick can then just loop through the components. I'm going to call this the comp just because it's shorter. Next, say comp tick, or not, because obviously the component wasn't a friend of the entity, or the entity's not a friend of the component, and because tickable, the declaration of the tick functions and stuff are protected, the entity can't call tick, but now it can with delta time. But obviously first we want to see if this is pending create. Yeah, if it's not pending create, then do that. And this obviously is saying can we make const. This really is const because this is a const function, I believe. And then obviously we can have pre and post tick in the entity as well. We now have a use for pre and post tick in the entity, where we loop through the components. And check if the component is pending create, then say component unmark for create. And then also we want to do pre-tick on this. I don't know if we should do this before or after this. What does the level do actually? That'll give me a good idea. The level with the entities on post-tick obviously does it before, because otherwise it's getting destroyed. And the pre-tick, it does it before. And yeah, I also want, you know, lifetime functions for components and stuff, and also a place for you to actually register the components, maybe, or something. I don't know. But yeah, let's go into the post tick. Why is that making it inline? Why are you inline? Why are you inline? What is going on? Okay, let's do it myself. There we go. Cool, right. So obviously post-tick is going to be difficult. We probably want to reverse iterate again over the things like the level does. It's a bit scary, but you know, I don't even know why I call the parent a function of this, because it's an interface. It doesn't do anything in it. I mean, just in case, I suppose. So, you know, we have the iterator, which will go for the components begin. If the iterator is not equal to the end, meaning it exists. For some reason this doesn't want to, oh, it's because it's R begin. There we go. We then can do an it, do a get, and then do a post tick, and then check if it's pending destroy. If it is, we can set it to be, okay, this is where it gets crazy. Declare the type of it, meaning we set this equal to be something which is being casted to the type of iterator, meaning we don't need to write out this long thing to put to a cast. And then we can say the components, we want to erase one because the erase returns an iterator. It doesn't return a reverse iterator, which is why we're casting it to a reverse iterator, which is safe, I believe. And then we do a next, which I'm not exactly sure what this does, I'm going to be honest. But then we do a dot base to get the base iterator from the reverse iterator. And that's the erasing. And then the else is just incrementing the iterator. So that means that no matter what, at any point in the loop, the iterator is always valid, which I think is a common pitfall of iteration loops, where you're changing what's in the vector whilst iterating, is every time you erase, the iterator then becomes invalid, and then you try and use it again, and obviously it either breaks the loop or it crashes or something, because it's not valid. So, but obviously when you set it here, you're setting it, the loop's end, the loop ends, it's now equal to the next item or the previous item, because it's reverse, and then it goes and does its thing again. So I believe this should work. Yeah. And obviously I've just realized, no, I haven't just realized, because that shouldn't, no. What I was thinking was, when we, you know, destroy an entity, we call entity destroy, which then calls despawn. Despawn isn't called just before it's erased. Despawn is called the exact same point that you're calling destroy, meaning that, you know, anything that is valid is still valid and stuff. So that is that. What else uses these? Obviously set texture and all that stuff. So let's continue working on the sprite component. We want some public functions. We have set texture and things. So set texture, we'll take in less of texture, obviously. And it won't only just be setting the texture variable, which it does do. Obviously we want to check if it's invalid. If it is, then we can just return. We also want to set the coordinates, which I'm just going to copy and paste because I'm too lazy. This is obviously because I haven't included texture. That's text. There we go, texture. So now we have a set texture. We also obviously want a get texture, which will be no discard. I believe this is how it is in. No, this is actually in there, but it's more or less the same thing. Yeah. And then we have a set size, which yeah, you can set sizes. Yeah, that makes sense. I don't want to, though. I don't want overloads. I just want the vector one, the SF vector, to get the size. I don't want the X and the Y ones. And obviously here I'm just going to copy and paste as well. Obviously instead of X and Y we do size.y, size.x, etc. Like that. And then we have get size, so obviously again no discard, which apparently can work fine as a const reference. I assume because, yeah, we get the position of that. So we can just return the vertices at the third index position. Because obviously this is just set to the size, meaning we don't even need an extra variable in the component for size. We can just use this as size, which is nice. We have color. Don't know why I made a color thing, but sure, might as well. Also, I swear color is a really small class. Yeah, it's 4 bytes. That's smaller than a pointer. Why don't we just pass it by value? That'd make a lot more sense, wouldn't it? So now we can do a loop on this. We have to do an index loop because I don't think the vertex array implements begin and end for its like array, which is annoying, but it's not the end of the world. So the color equal to the color. Obviously my British spelling of color versus the American. And then we can have a no discard for guessing the color. And obviously because once again but you know, all of the vertices have the same color, we can just return the first one, or any of them really. And then so that's all those. Are there any more? There's collision, which is fine. Serialize. Okay, so if I get rid of this, I get rid of these, I get rid of, I'll keep global bounds, but I'll change what it means. Destroy. Yeah, I'll need to work out the cleanup and stuff as well for those things, but in here now we have these don't need to exist. And then obviously this as well, I'll need to do something here. Set size, just get rid of that, and then set texture obviously. You know, I'll just get rid of the size one altogether. Up here, I'll fix that in a bit, and then up here we don't need this at all. We just have this be a default. constructor. So here we want to get the bounds of all of the components combined. Say components comp, and then make a local float rect, call it like bounds or something, and then I assume we want to do something interesting. We want to set the set the size to be the largest, the most outward kind of bottom right corner, and then set the position to be the most top left corner. So there's definitely a better way to do this, but for now I'm just going to say if the components get global bounds, size, that's the bottom right position, is, can you even do a greater than with a vector? Is greater than this bounds dot size. What's this component about? Oh, one's int and one's angle. Can't convert float to, neither of them are angles though. I think it's just because it only has this for angles or something. So we need to say dot x is greater than dot x. Might just have to do it on a single point basis. Then we can set bounds dot size dot x equal to global bounds dot size dot x, and then do another if for the y. So it's definitely not a good way to do it, but it should work for now at least. And then do this, but get the position and see if it's less. Go through, do the positions. I'm just going to copy this, and then for the y here, here we go. Okay, and then we can return the bounds. So this is obviously going to be 0 by default, and then if any of these are true, then it is, you know, more, better, whatever. So it just goes through each of the 4 corners, checks if they're less than or greater than or whatever, and then, you know, sets it if it is. It's not terrible, surely, but anyway. So the entity is fine now. The destroy, I don't know if the components need to know if they're being destroyed or not. Obviously they don't have any kind of lifetime things like, you know, create or destroy or whatever. I'll probably add them later, but they probably need to be serialized as well, so they can probably inherit from serializable. So let's make these into a nice list. Yeah, make it inherit from serializable. I just want to see if any of these include serializable. Yeah, no, interesting. Anyway, yeah, so serializable, we have these 2 functions, serialize and deserialize. I think they can be private. Yeah, I'll make it protected. Serialize and then actually no, we don't even need these because we don't have any members here. So this sprite component here should have serialize and deserialize. I don't know what it's going to do, but at least it will be a concrete class. We also need to do draw and tick. Tick won't do anything, I don't think, but draw will. Here we just need to say the states dot transform, multiply the current transform. We can then say states dot texture is going to be our current texture, and then we can say target.draw our vertices with these states. Obviously we need to include the render target as well. There we go. So yeah, I don't know what I'm going to do for tick. I'm just going to leave it empty, I think, because I don't think we need to do anything on tick. In the animated sprite component we will, because obviously we need to use tick to know what frame we're on and to move on to the next frame and stuff, but for a normal sprite, nothing. But we still want to be able to actually allocate it, so we don't want it to be abstract, and it's not, so that's good. It can be made final. I'm not going to make it final because obviously we're going to inherit, but I'm thinking we want these to be protected then, because obviously the animated sprite component is going to be wanting to use these members, I think. So we could just have getters, but I don't think there's any harm in having them be just protected. So I think just having all of these be protected is fine. So I think this should be fine. The entity obviously is all good. Yeah. Yeah, although we need to remove a component as well. So create, should I just call it destroy component or remove component, or let's call it destroy component, might as well. Destroy component, the component in question will be this. Yeah, sure. And this would be like the levels when it was just cool, like destroy on the thing. I was like, where is this function? It's here, okay. Yeah, because the level, the destroy entity just calls destroy on entity. However, I don't want to be able to just destroy a component by itself. The components are managed by the entity. So although the entities are managed by the level, the components are like ingrained as part of the entity. So the entity should manage all of the lifetime things of the component. You can't just arbitrarily destroy a component, I don't think. So yeah, although you could wrap it or whatever with the components thing, I definitely just feel like it'd make more sense as the just to explicitly state from the entity. So we want to say component mark for destroy, and then also have a some kind of function. What do I call it? Because I can't call it destroy, can I? Because that would clash with the entities thing. But I can't call it spawn. I'll call it destruct. I'll call it destroy. I don't know, man. Yeah, I'll call it destroy. I'll make another one for create, on create and on destroy. So here we'll say component destroy. It's the same, we can make it static. That's true, actually. That's the same for the level, I think. We don't even need to have it be a member. I'm not going to make it static because it just wouldn't make sense, I don't think. But yeah, I think having this function is more about how you perceive the component is getting destroyed, because obviously you're not actually altering anything apart from marking it for destroy and calling this function. And you could do that on the component. You don't even need a reference to the entity. All of that is on the component. So you could just say, destroy component anywhere, and as long as that has access to those two methods, it can destroy the component. But yeah, it's more about the presentation of it, I think. So we can destroy this. Obviously, we want to check if it's valid or not. Should probably do that in the level as well. I don't know if I do that in the level. Oh, I do. If it's valid, then do that. Yeah. Okay. Yeah, so I think that is more or less it, isn't it? You create it, you get it, and then you destroy it. I'm still not sure about this name, but anyway. I do want to have a function called which gets the entity like parent that owns it, or outer even, not parent. Yeah, and also if we're doing like Unreal stuff, it would be more like a tree where components can have children. So you have a root component of an entity, and then you can have children components and stuff. But I don't want to go that deep. I don't think. I could restructure it, but yeah, I can do that later after a bit more thought or something. It would make sense too, but I guess it doesn't matter that much. Anyway, we can say get owning entity or something, which will just be return get typed outer, although this should probably be in an implementation, meaning we need a source file for this. This should also be a no discard. So we need to add a source file for this, nice and easy. Just include the tails component header, and I think this is how Rider knows which source file to like add the implementation to. Is just it finds the one with the include or something. I don't know, dude. I'm just making stuff up at this point. Just lying on the internet. CMake. We want let's put it above the sprite component. We can rerun CMake. And what do you know? We got that. So now we can just, there you go, automatically does that. So now we can just say return get typed outer entity. And obviously this isn't going to work because we haven't included entity, so we need to include entity. Like that. And it should be the immediate outer, so I don't even need to say get typed outer, but I might as well. So there we go. Nice. So we have our sprite component, and that's all we need for the game itself. We have our player, which I want to refactor, because obviously we have stuff like this which isn't working. So let us have a public constructor, otherwise we can't instantiate it. And let's say we want a pointer to a sprite component. Sprite component, we want to just call it sprite. What is going on here? It's not initialized and then default. Okay. Well, we can say sprite is equal to create component, and it's not registered either. Should probably do that. We can just include tails sprite component, C sprite component, and just do that. So now we're creating a component. Set it equal to this, or set sprite equal to that uni make component, meaning that here we can say sprite component set texture, and we should also probably set the size of this and stuff by default as well, like we were in the entity. We set the size to be what, like 16 by 16. I can't remember what else I was doing. Maybe I set the color as well. I don't know. The color is going to default to white though anyway. There we go. So if we do that, I do want to quickly go and what was the No, I just have the thing, don't I? What am I doing? I have this register class. Yeah, register class custom name. No, do I want the custom name? What am I doing at the moment? Am I... Okay, I'm just registering class. Because I was thinking we could just say entity instead of C entity, right? But whatever. Sprite component here. We'll register that. So now it's registered. We could, in the player, say, you know, C sprite component. And then obviously this casts to it or whatever. And we could just get rid of that if we wanted to, but then this wouldn't match up. And this needs an open bracket. Yeah, but you know, anyway, let's just not look into... No, let's look into it, because then we can find if there's any bugs and stuff. So we have the sprite component, and then this should work just fine. So now if we play it, probably going to get compile errors or something. It's going to recompile the updated SFML and stuff because I'm using the master branch. But once it's done that, we can hope that the Tails game, well, that the Tails engine compiles, and then the Tails game compiles, and then it runs fine and works. What we should see is essentially exactly the same that was happening before, and that would be brilliant. The visuals shouldn't change, basically. Okay, sick. I don't know where the other thing has gone. Oh, because it doesn't have a component, obviously. Obviously. So we can just create a component here and say C sprite component. There you go. Let's do that. And then it should be exactly the same as it was before now. Yeah, brilliant. Component system works. The registry for the component works and all that jazz. This is brilliant. Yeah, as you can see, we registered C entity, we registered C player, we registered the sprite component, and that's great. The sprite component is 312 apparently. What makes it 312? Interesting. How big's the entity now then? 286. Interesting. Right, well, you know, that's pretty sick. I do want to... I'm going to do like animated sprites and stuff later. I do want to quickly see about a camera component, because I've been thinking about how I would implement that. And I think I know. So we go here and we say camera components. Like, you know, you can switch between cameras in the scene and stuff. Super cool. Tails camera component. And then obviously got to make a source file for it. I will be honest, this is probably the worst part, or one of the worst things about C++, just the fact that you've got to keep track of two separate files for each like class or each anything really. It just gets a bit annoying. I suppose the two file thing is mainly just a C problem, which I suppose is fair enough, it's an old language, but modules should be really cool if they ever get fully implemented, or ever, like, you know, people actually use them. But they should be quite cool, I think, modules. Anyway, camera component. What this needs is obviously to inherit from component, but also a SF view, which will be the actual camera. So we have a private here, SF view, just call it camera. Let's call it view, actually. And then here will be the public stuff. So I'm not exactly sure what the interface for this will be like, but what I do know is I want to be able to change the active camera from within the component, and then the level then uses the active camera component to display what's happening. So we can say set active, and this will simply query the level, which needs to also change stuff, because at the moment the level just has the camera and that's it, the camera for the level. This, what I want instead is either a pointer or a reference to a camera components view. So we can call this like default camera instead, so that if we don't have an active camera component, then it'll actually display stuff as a default camera. So let's call this default camera, and then we want an SF view reference, and just say camera. Let's call it default view. Let's just keep the name view around. This is obviously not going to be initialized. Can I say, like, you know, is equal to the default view? Can I do that? Have you used type of... Okay, so apparently you're not meant to have references in. Okay, whatever, let's just do that, and then that. Yeah, okay. So obviously now we have get camera view. We don't want that. I don't think we want to be able to get the view of the level at all. So draw, we're going to set view, and we do want to get, actually no, maybe we want to get the active camera view. Yeah, let's get the active camera view. And then like this. So we can say, you know, if view, then return the view. It's a view, but I don't make this a float rect. What is this complaining about? Nothing, okay. And then if it isn't valid, then return the default view. Although, no, it should always be valid, so it should just always return view. And we could actually make it a constant reference as well. Kind of depends on how big view is. Oh yeah, we want to make it a constant reference. And we can just return mView, because this will be pointing to camera view by default anyway. So then down here we can say set view to get active camera view. Okay, cool. Now we have that. We want to have some kind of function for the camera component to call to set the view. So set active camera. We can bring in the camera component. Here. Set active camera like this. Should probably make it a reference. No, it's easier for the outside server as a pointer. So if camera is null, then just return. But if it's valid, then we want to say mView is equal to the camera or is it camera component header. Get the view here. like that, get the view. So then in the level, we can say get camera view. And obviously this is const, this isn't const, etc. We can make a non-const version as well. So now this is still complaining because this needs to be that. If this was const, would that still work? No, okay. Let's make it the address of 6, it's a pointer, and now it's the active camera. So that's good. We can also just have an overload for just the view as well. It's active camera view. It's not really an overload, but constant SF view, call it view. Although actually I'm just thinking this probably wouldn't, hang on, this probably wouldn't work, right? Yeah, because it's constant. It shouldn't be constant. There we go. So we can set it to a camera, we can set it to a view, we can get the view, and that's all good. So now we just need to call that. So in here we can get the level, and we can say we want to get the level, so we want to get the owning entity. We want to include the entity as well. And then we want to get the... Do I not have a function to get the level in the entity? Do I not? Wait, what? Oh, it's protected, that's why. Okay, let's make it public. Yeah, let's do this. Here we go, get level, and then set active camera this. Cool, and then we have that. So now we can say, we can do a check for like if it's active or not. Is camera active? Return if the camera get camera view is equal to the view in here. We can't test the equality of SF views for some reason. What can we do? What operators does this overload? None. Okay, what does a view have as its contents? Okay, I mean, could we test the address? I'll do a mark sets do test equality of views or something. So if they equal, then obviously it is the active camera. And then in the camera component, we can just wrap that. Is active. Return the get owning entity, get level dot is camera active. This this is wanting a const. Wait. Can this be const? Wait, hang on. Level. Yeah. Okay. Brilliant. Cool, 7 is active and stuff, and that's all good. Yeah, so I don't know what the... I do have a world that I... Yeah, I don't know what the kind of default... Yeah, here we go, this. Here. So I'm thinking we say results set active camera view although that's non-const, so actually yeah, no, we can just say default view, can't we? There we go. So now if we run it, it should still work the same way. We have a thing saying get camera view is not a member of C level. Oh yeah, obviously. Let's ignore this for now, because this will have a camera component that gets active. Okay, cool. So the view still works. It doesn't follow the player, obviously, because we took it out. Let's add a camera component to it. Like so. Let's make a thing for that. Say camera, and then we could say m camera is equal to create component, camera component. Put it in here, see camera component, like that. And then instead of this, we can say m camera we can get the camera view. Although actually, do we not even need this? Because since the camera is moving since, like, with the player, I don't think we even need this actually. Oh, never mind. Oh, it's not registered, okay. I should have seen that coming. Obviously it's not registered, there we go. We need to obviously relink or whatever. And cannot instantiate abstract class. Oh yeah, obviously, because we don't, you know, tick and draw and stuff, we don't implement those. If we go final, it will tell us what we need to implement. No, it won't tell us, never mind, I lied. We can have private because I don't really intend on, like, instantiating this. So we can say, what is it, tick we need, and draw, and serialize, and deserialize. Is it still? No, okay, cool. Let's relink again. Yeah, I think it told me down here actually, because there was 4 error messages for the 4 functions, I think. I don't know. So no, just because. Actually, no. Wait, I don't even need to draw anything. Yeah, no, I'm thinking because the camera should move with the character, right? So what I'm thinking is we have the view here and we set the center to be the position of this. And I think we just have that as default behavior. Or whatever this means. That's okay. Invalid selection for comdat section whatever hex number. So it's a linker error. Okay. So interesting. Let me look this up. Okay, so apparently it can't understand MSVC's compiler if there's object files compiled with other things. It doesn't understand those, so it must all be compiled with MSVC, obviously. That's what I've been doing. Why is it starting to do this now? Okay, so apparently the object file is corrupt. Meaning what? Try and recompile it? Okay, so it just means that it's corrupted or something. So this obviously isn't working. I mean, just to make sure this is being called, let's have some debug stuff. Let's just say tick. Oh wait, you know what? It's the problem, probably, maybe linking. I mean, I'm just saying. Okay, so it is ticking. It's just not doing something. But is it? Its position is getting set, isn't it? Because the entity. Yeah, obviously, all of the components have their transforms done or something. What is its? If I go to the tick in here and I say print, and I want you to print me the sprite X. So we say the sprites get position.x, and then I say camera X. Right, and I say camera get position.x. I do that instead. What is the result of that? Okay, so their positions are all 0, even though the sprite is moving on screen. It's only because the states are changing, meaning its actual position is still 0, which I suppose makes sense, but I feel like I want its position to be 0. No, to be, because how would you get the relative position then? You know what? We want to, yeah, no, we can just say set center to the get earning entities position instead, because you know there's like relative position and like global world position or whatever. That's still not doing anything. Wait. Hang on just a second. There's no way that the entity's position is also 0. No. Okay, the entity's position is indeed changing. It's just that for some reason the camera isn't using that position or something. Let's see how they stack up against each other. Who's right and who is wrong? They're both the same. That's good. But it doesn't help me in any way, because this should be set in the sensor, no? Unless setting the sensor. Well, no, because here before, right? Here before we'd say get level, get active camera view dot set. Hang on. There's not a non-const version of this, but you would say set sensor, no? So why in this camera component is that not working? Unless there's another one here where we say, you know, set sensor, set size, set rotation, set scissor, set viewport. I want to try something. Let's try moving it. Oh wait, no, wait, is it just because it's not active? Hang on, I may just be stupid. I think it's just because it's not active. I never activated it. I never activated it. I never activated the camera to be the current view camera. Okay, okay. So we're making progress. We have whatever this is. Obviously, it's not the right size, but it's doing what it should be, at least, which is the good thing. So we obviously need to, when it like initializes or something, we need to get the world thing. So this might be a bit botched, but hear me out. In its create method, we say get owning entity, get level dot get let's just get the active camera view, and then we can just we should say mView equals this. So we just copy what that is. Yeah, or maybe only copy the size or whatever, right? Okay, never mind. I don't know what's going on there. No, it's because this is probably getting set before the. Hang on, I think this camera is getting set as the active view before this create is called. Say camera create, and then in player we say activate camera. No, it might, because spawn gets called before it. Yeah, I think it genuinely might, but we can't get the level in the constructor. Yeah, activate camera is called, but create is never being called. That's the issue we have. Create is never being called. So we can probably, yeah, we should probably, what is it? We should say what, initialize component or something, or yeah, I'll just call it initialize component, and we can take a unique pointer. In like that, and this initialize component will just do these things basically, where we create the new objects thing, but we actually can place it and stuff in here. So we say components dot in place back, move the component in there, and then return the back here. And obviously then, actually before we do that, we want to like do that, say comp create, bang, and then return comp. What's this all about? A declaration of comp hides, let's call it results instead. That's what I normally use. Yeah, and then in here we don't need this. We can simply just say initialize components, new objects, we'll type T, but this is the outer. And then in here, same thing, but we can cut this. Say initialize component, paste that in there. And then in here, we can simply just say same thing, cut this, and then return initialize component this. Although this is obviously not a unique pointer, this obviously isn't a unique pointer either. So we do need to put them in a unique pointer of type T, like that. Or make unique or something. Same thing here, I think, although this would need this could just be component, right? I think. Yeah, anyway, this is, fine, I think. So then now create is being called, and it should get the levels thing before spawn. Or actually no, it won't, because obviously if we're doing it in the creates here, which is being called in these functions, the create component functions, those are being called in the player's constructor, meaning the player's outer is not set. So it's just maybe a botch, not really a botch. So it's not a botch. We have a init components function or something. So that called before spawn, used to initialize this entity's components. Okay, cool. So now we obviously need to call that in the level. So wherever we're spawning the entities before spawn, we can load the resources. Although before that, we want to init initialize init components, and then nice. That's good. I just 'cause it's naming things, I want to call this init. No, not init. Setup component instead. I should probably just find the declaration of that instead. And in fact, nothing here. That's nice. Well, that's useful. Okay, setup component. These for some reason don't have IntelliSense or something, so we do that. And then in here we say that, and then in here we also need to go down and say that. There we go. Okay, so what happens is our level spawns entity, the entity's position stuff gets set, then we initialize the components of the entity, we then load the resources, and then we spawn it. So that means that the entity's outer is set before this function even gets called, which is good. Because obviously it's set as soon as the thing's created, because it's a new object function. So that's good. So hopefully this should work. Or not. Oh no, it's because I'm still in the player, I'm still making them here. Instead of the init components function here. Don't need that anymore. These can be initialized with null pointer. And then we can play it. Bang. That is absolutely brilliant. That's brilliant. That's awesome. We have components. We have a camera component that can get set to active and stuff. And it just kind of it just works really. When you make an entity, it's just like, yeah. So I think that's it for now. More components can be created later. I do want to do a sound component or music component, stuff like that. Animated sprite component. Nothing else is coming to mind, but I'm sure there'll be kind of lots more things that, like tiles. Yeah, I can finally actually, start implementing loading levels, which is that would be very nice. Yeah. Also, if you're wondering, the window properties says my epic game because I did do some experimenting with the JSON, because not everything in this kind of like series, I suppose it is like recorded. I do some like small stuff here and there just to test things or change a few things around just to make sure it works a little bit better. Obviously, if you want to see all those, you can go in like the commit history on GitHub. Although a lot of the commits from the videos. They get committed like a day after. No, they get committed a day before the video gets uploaded, because obviously I need to edit the video, and that normally takes like 2 hours or something. And then it uploads. It takes like 2 hours to upload because it's really long. But in the, what is it, debug? Yeah, in here. Not in here. This is an old build. It's a very old build. This one here. We have a thing going on. Okay, I don't know what that is, but anyway, we have this. It says My Epic Game. No, this isn't the right build. What is going on? What is the right build here? This one. This. The build from when you open it in Rider. This one uses this directory. This is the JSON that the engine loads. It looks it as the directories, which is why you have these here. It doesn't seem to print them all out properly every time. I don't know what's up with that, but these are the directories. Then we have the rendering stuff, resolution, and then we don't have the default level because I haven't done level loading and stuff, but the window properties here, we have My Epic Game and then X and Y. So when we play it, you see we have My Epic Game at the top and it's 1080p. I'm on a 4K screen, but yeah, also notice that the camera is pointing towards the top left because that's where the origin of the player is with the position. I don't really care, you can change that in like your own code. The engine doesn't need to change that. Anyway, I've been rambling on a lot. That's it for this video. Sweet components. Have fun.